Welcome, everyone. Good morning, good afternoon, or good evening, and welcome to this Techstrong learning experience brought to you by Oak9. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we do have an exciting program ahead. First, I have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you missed any of our discussion, perhaps you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after our live session concludes. If you look to the right side of your screen, you'll notice there are a couple of options that you can use to engage with our panel today. The first of which is the chat tab. So I'd like you to start warming that up for me now by letting us know from where you are joining us. If you look to the top of the chat, you should also see a couple of links that I've posted. You may need those later in this program. So if you do find that you need them, just scroll all the way to the top. Now, for any questions that you have, we do request that you send those in to us using the Q&A tab, which is directly to the right of the chat tab. We will have a couple of polls that we'll be launching throughout our program today. So when you see those pop up, please do respond, as we'd like to hear your thoughts on those. And if you navigate to the handout section, you'll see there are 2 extra resources there for you. So feel free to grab those. Of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around to see if you're one of our winners today. So our workshop today is on Terraform Cloud, security beyond static misconfiguration checking. And I'm joined by Ramesh Patel, Director of Cloud and DevOps at Oak9, and Yash Khemani, Solutions Engineer at HashiCorp. Ramesh and Yash, thank you both so much for joining me today. Ramesh, would you like to go ahead and get us kicked off?
Sure. Thank you, Cody. And hello, everyone. Thank you for joining. We have an exciting demo to show off today where we'll be showcasing a full-fledged out CI/CD pipeline using DevSecOps principles. My name is Ramesh Patel. I'm currently the Director of Cloud and DevOps at Oak9, based out of Chicago. Oak9 is a cloud security SaaS product focusing on infrastructure as code security and security as code. Our platform dynamically secures your infrastructure as code and deployed workloads automatically. We do that by integrating with many IAC languages out in the market, cloud vendors, and CI/CD tools. We also have a community edition of our platform, which I urge everyone to check out after this demo and give it a spin. Now I'll pass it over to Yash for his intro.
Hey, Yash Khemani here. I'm a solutions engineer at HashiCorp. For those who may be unfamiliar, HashiCorp makes tools to enable you to adopt the cloud operating model, both in public as well as private clouds. We have software that enables you to provision, secure, connect, and run your applications in any cloud in any environment.
Thank you, Yash. Let's go ahead and kick off this webinar or demo today. I'm going to share my screen here. Yash, can you see my screen?
It is loading. Yes, I can see it now.
Okay. All right. For today's demo, for everyone on the call, we're going to be following a particular documentation that's been written up and that's publicly available online. The URL for that documentation is learn.oak9.io. This is where you'll find all the instruction set for our entire demo today. We'll be starting off by setting up a DevSecOps pipeline. We'll set up that DevSecOps pipeline by using Terraform Cloud and also the Oak9 integration in Terraform Cloud to give back the secure design gaps for that particular Terraform Cloud provision. But before we get started and before we go over the repo and the repo structure, the first thing I like to kind of talk about and kick this demo off is we like to talk about DevSecOps and what it means to an organization or what it means to folks out that are implementing this. But before we do that, the first thing I like to do is take a poll on how do you identify security and how do you enforce security, or who is responsible for security in your organization?
We need an option here for all of the above.
uh, that is true. Okay. So Yash, do you want to kind of just give us a 411 on DevSecOps, what it means to you, what it means to your organization?
Yeah, absolutely. Let me actually share my screen, and we'll just kind of walk through in a little bit of a whiteboard. Great, and you should be seeing my screen now. Yeah.
Yep, I see it.
Excellent. So, when we talk about DevSecOps, right? Yes, we have, the idea of you can say the buzzword bingo of the day, right? But what does that really mean, right? Or if we think about it kind of in an opinionated way, how do we go about doing what we call DevSecOps? So, when we are working within an organization, we have many people who are going to collaborate, right? When we talk about provisioning infrastructure or doing security, connecting applications, running applications, we want to codify everything, right? And so our focus today is, of course, going to be infrastructure as code, right? With Terraform, we do that using the HashiCorp configuration language. And as is not uncommon, this is going to end up going into a version control repo, right? And we collaborate with one another. We check this out. We add to it. We modify things in it, and we push it back, right? Hopefully, the way we're doing this is by creating like a pull request, right, which will then get reviewed and merged. And of course, the fact of the matter is that people also push directly to the repos. That does happen. So this approach over here, how do we leverage this kind of pattern that we use for really all development and weave security into it, right? So with Terraform, let's kind of focus on that piece of it, right? Which I'll kind of draw with a big T over here. Terraform, if you've worked with it, has a concept of a workspace. A workspace you can think just as a logical grouping of that codified infrastructure pattern for provisioning some related group of resources. So what we want to do is actually, have a webhook relationship over here. And what that does is it brings into Terraform the configuration, right? That IAC that we've developed, and really what's coming in is the infrastructure as code from a particular branch. Now, if we want to, develop a new feature, right, or maybe we have a break fix that we need to introduce, those are going to be in their own branches, right? And they'll get merged back in, right? So a common pattern is whatever branch it is we're working on, we want to take that successively into the different environments for that application, right? So let's say what we're developing here is, we'll just call it app one. It's going to make its way into the changes we have from that feature branch or that break fix branch are going to make their way into dev, then stage or test, whatever we call it, right? And then finally into prod. And there's a corresponding relationship to a workspace in Terraform Cloud for each of these environments. So we have the configuration. We're also going to instantiate that configuration with a set of variables that we define in our Terraform Cloud workspace. The next thing that Terraform does when it gets this webhook, right, whether it's for a PR or that PR has been merged, it's going to do a plan. That plan describes the changes we need to make in order to deliver what has been codified in the real world, right? Whether that's public cloud like AWS or Azure, or it's private cloud like VMware, Nutanix, OpenStack, and platforms that run on top of that like Kubernetes. as well as software that we're taking a codified approach to managing the lifecycle of. The plan describes what it is we're going to do, but the question arises again, the security part of DevSecOps. We want to weave security in right from the outset. So the next thing that happens is run tests run, right? Now, I'm putting it over here post plan. You can actually configure run tasks to leverage pre-plan, post-plan, as well as pre-apply. Running it post-plan, which is what we're going to do with the Oak 9 run task integration today, allows us to leverage the plan as well as the configuration to determine whether what we are doing is compliant and secure, right? So this is where the Oak 9 integration comes in to make sure that what we're doing is compliant. And compliant not only in the terms of security, but also our best practice standards, right, that have been codified. So in order for us to proceed past this point, this check must pass, right? If this check fails, that acts as a blocker, and we're prevented from proceeding. So when we create that PR, a speculative plan is kicked off. So we don't, we're going to only go to a certain point. In order for that PR to be merged, oops, sorry, wrong color. In order for that PR to be merged, these tests that we're talking about right now must pass. The next thing that comes after this that Terraform does is cost estimation. This is just leveraging the cost estimation APIs from your public clouds like AWS and so forth. And then we do a security check, right? So this is using the security as code Sentinel policy language. Oops, sorry. Or you can use OPA, right? But same concept here. This acts as a gate. So this must pass in order for us to proceed. If it fails, same thing. This acts as a blocker, right? So everything I've drawn out over here from the plan phase through this security check phase, this happens each time there's a Terraform run, whether it's a speculative run or an actual apply. So if all of this is valid, if all of this passes, we go on to do the apply. And that, of course, pushes things into our fluffy clouds, right? Our AWS private cloud, whatever it is that we're provisioning. And then we get back from this process a state file, which gets stored in the state history. And we use that to iterate upon the infrastructure on day 2. And we also can use it at the end of the life cycle of this infrastructure to destroy it, to retire it. Right, so kind of if I zoom out in terms of what we just talked about, this is DevSecOps in the infrastructure provisioning workflow. Now, this is all really cool, right? And it's always nice to work with cool tech. But what is the value of all of this, right? Really, it's 3 things. We want to be able to increase velocity, meaning we want to enable our developers to go faster. We do this through enabling self-service. And we didn't talk about other aspects of Terraform Cloud. I wanted to keep it focused on the GitOps workflow of the run task integration with Oak 9. There's also a private module registry where we place our curated codified patterns, our modules or functions that our users can leverage to come in easily and say, in our organization, this is how we do Java applications, or this is how we do Node.js applications. This is how we do MongoDB and so forth. So in order to do that, we need to consider risk management, right? We're enabling self-service. We're enabling our developers to go faster. We need to also manage risk, right? And we, of course, are doing this with these inline policy checks, right? So part of your Terraform provisioning workflow is these checks to ensure that what you're provisioning is compliant, right? That acts as a gate. If it isn't, if we're making a violation, we're prevented from proceeding. And of course, the other thing we're doing is we're managing cost. We're significantly reducing costs, not just through the cost estimation API that helps us avoid excessive cloud spend. Finance will be very happy about that, but also in terms of operational cost, right? Reducing that friction between developers and the operations or platform team, where rather than putting in tickets and waiting for infrastructure, putting in another ticket, waiting for firewall holes and things like that, we give developers the ability to proceed in a more effective manner. We allow platform teams to operate in a more efficient manner, thereby reducing operational costs. We can do more with the resources that we have. So that, at a very high level, is kind of the workflow. And what we've described here, of course, is the GitOps workflow. But whether you're interacting with Terraform via the VCS connected workflow, or you're coming in from a CI pipeline leveraging the Terraform Cloud API, all of these checks that we described get enforced. Similarly, if we're a developer, we're working from a CLI and we're interfacing with Terraform Cloud that way, all of these checks get enforced so that what we are provisioning is compliant. And we'll actually get, Ramesh is going to show us this in action today. So with that, and I'm happy to take any questions in chat, but I will hand it back to you, Ramesh, to take us through your demo.
Sure. Thank you. Yash, you have really good handwriting, by the way, much better than mine.
Oh, thank you. This is I'm very much a kindergartner. I draw all day long. It's like people ask me, what do you do for a living? I draw.
So yeah, Yash kind of went through the GitOps process and talked a little bit about DevSecOps. But yeah, overall, DevSecOps is a principle and a methodology that organizations will adhere to allow security guardrails to be implemented at a very early life cycle of the SDLC life cycle. And we're going to walk through that, and we're going to go through how to do that just by following this demo. So let's kick it off here. This demo is going to do a few things, right? We're going to take and fork a repo that's created for this workshop, and what this repo is going to do is going to set up a simple API in our cloud infrastructure. And this API that we're going to deploy is going to use a few cloud resources. It's going to use an Amazon API gateway. It's going to use a few Lambdas. And these Lambdas are what does our CRUD REST API operations. And then it's going to be backed by a DynamoDB table, which I think I left out, but there's a DynamoDB table here. And what we're going to do is we're going to deploy this API in a vulnerable state and push it through our pipeline. And in that vulnerable state, we should see our design gaps and our security guardrails kicking in and showing us that, hey, you have an API gateway that's publicly accessible to the internet. This is not good practice. You should fix it. And then what we'll do is we'll implement that authorizer functionality live, and we'll go through and run the pipeline again. And we should see that our design gaps are green now. The same drawing that Yash kind of drew up, we're going to do the same approach of implementing a run task. However, we're not going to be doing the branching strategy that you talked about in the interest of time. Okay, so let's kick this off. The very first step that we have to do in this demo is fork our repo. So let's go ahead and fork this Terra Oak Workshops repo into our own personal repo. One thing I forgot to mention, I'm sorry, is that there is a whole bunch of prereqs that should have been fulfilled before this demo. And those prerequisites are all on the first page here. But if you did not do that prior to this demo, no worries. This is all accessible later on, so you can go ahead and run it. You can even use the Oak9 Community Edition to do all this, and the Terraform Cloud free edition to do this at your own time. All right. So we're going to just fork the master copy of this repo really quick into your own personal repository. That's the very first step. And then once that's done, right, we want to follow this documentation and go ahead and set up our Terraform Cloud. And the very first time you log into Terraform Cloud, as Yash kind of alluded to, we have to do what we call setting up our workspace and setting up our organization. And what that does is it gives you or your team a particular area that you can use in order to deploy this piece of code. So if you have multiple teams that are needing different workspaces, you can go ahead and set all that up in Terraform Cloud so that the state file is independent of each of these teams. But in our case today, we're just going to have one workspace. And then once we set up the workspace, we're going to set up our VCS integration. And the VCS integration is going to allow Terraform access to your GitHub repo. It's an app integration within GitHub. And once that's pretty much done and you have your VCS integrated, we'll go ahead and also hook up the run tasks. So let's go ahead and do this Terraform Cloud part first. The very first time you log into Terraform, you'll see this start from scratch screen, and you can just come up with the organization name that is suitable and not taken. Mine is not taken. I think I deleted it, but we'll see. All right, and the next step is to set up our version control, which seems like it's a few clicks. And I am authorizing Terraform Cloud. For the purpose of this demo, I'll just do all repositories, or you can only select repositories. Actually, let's just select our repository to be secure. All right, so we can keep it as a default project. We don't need to do anything there. And I think what we want to do here, yeah.
Can we have you hit Command plus a couple of times to increase the font size? Thank you so much.
Sure.
Great.
Is that good, Yash?
Yeah, that's lovely. Well, it's lovely for me. Hopefully, the folks who are on smaller screens are good too.
Yes, if it looks too small, just yell out on the chat. I can increase the size. So I'll keep it a default project, and all the Terraform code actually sits in our users API. So this is why I made the working directory users API. And the apply method is a manual operation. We don't want it to auto apply. We want to intervene and say, hey, apply it when I say to apply it. And then we want it to run, a trigger a run when we make any edits. And then the default branch here is master, but I don't think you need to put that, but we'll put that in there anyways. And speculative plans is when a pull request is created, I'll go ahead and kick off this integration. So we can go ahead and create this workspace.
Hey, Ramesh,
and now
yes. While you're doing that, if I can interject a
sure.
question that was asked. So can you talk about how security checks are enforced in Oak 9 and how far the checks go?
Sure. Yeah. The security checks in Oak 9 are enforced by a profile that you create in Oak 9. So when you register on Oak 9, you will go ahead and create an account, and you'll go ahead and create a profile for your particular project. And based on your business sensitivity and based on the decisions you make when you create your profile, we create a dynamic set of blueprints that will fulfill your organizational needs or compliance needs. And then that blueprint is what gets applied to your project or this integration that we run here. But we can talk about a little bit more about that when we do the run test configuration as well.
Perfect. Thank you.
Yep. All right. So we have to configure we have to configure a variable here for our AWS integration so that we can deploy variables and integrate into AWS. So we'll add a few variables here. And you can go inside the AWS documentation. As you can see, I'm very lazy in typing. I'll go ahead and do this in a separate screen just to make sure it's sensitive. I'll put that in and I'll bring it back.
So wait, we don't get to pick up your cloud credentials? That's what I came here for. Yeah, so in Terraform Cloud, when you're setting variables that are sensitive, you can mark them as such. Of course, in order to do so, you have to have permissions to be able to set the values for variables. So it may be that you have someone, or really some process, some CI pipeline that injects things like cloud credentials, but marking a value as sensitive enables the workspace to use it, but it is write only, so you can't see the value once it's set.
All right. And that's been configured. So we have our two variables that we need to provision our infrastructure, and we're good to go there. All right, so the next step in this process is to make sure that you change your plan here to allow the team and governance plan. This will allow us to run tasks which we'll configure next. So let's go ahead and change our plan. And let me know if I'm missing anything, Yash.
Yes, you can actually click on that upgrade link on the left. Yep, you're there.
Yeah, I just saw that. Yep.
I know I get thrown off when the fonts are larger, and
yeah,
Yeah.
I feel like an old man right now reading a screen.
I am an old man, so I'm glad you can appreciate.
All right, so the next piece of this is let's set up the run task, and then we'll pause for any questions, and then we'll run through our demo. So the run task is pretty much similar to the Oak9 configuration. I'm sorry, the cloud configuration, right? But the first thing you have to do, did it enable? Yeah, there you go, run task. You have to create a run task here, and we'll call it Oak9 webinar test. And in order to configure a run task, you do need to have an Oak9 account, and there is a community edition, so you can go ahead and sign up for that. And the way you create a run task is actually by going to integrations here, and then selecting a particular integration that you need. And in our case, is Terraform Cloud. This is an old one, so I'm going to delete this guy. And I will delete these keys. So even if you see them, no worries, they'll be gone after this demo. So the webhook URL is the endpoint URL. And then the API token is the HMAC key. And then we'll go ahead and hit close here. And it's in pending state. So once we create our run task, we should get out of the pending state.
So what we've done here, what Ramesh has done here is he's enabled the Terraform Cloud Oak9 run task integration for the organization.
Yes.
And so it's available, across the different projects, but it needs to be enabled now for each workspace. So, if you have a process for vending out workspaces, right, part of what you'll do You may use the TFE provider to manage your Terraform, or through an API. But the process of providing the workspace to the consumer of that workspace is configuring the run task integration. So it's not up to the individual to opt in that, hey, I want to use this run task. It's the organization owner that is saying this run task will be enforced on your workspace that you're going to use.
Right. So what I did was exactly what Yash said. I created an organizational run task. Now I came into my workspace here, and I see that the run task is available, and I can sign in or apply it to my particular workspace here, and I'll go ahead and add it to my workspace. And what do I want to do? What do I want to do with this run task? In our case, for our demo today, we're going to be running this post plan, and we're going to be doing it as an advisory right now. And we'll hit create.
So with advisory, it acts as a warning. You're not prevented from proceeding. But whereas if it's mandatory and you have violations, it will act as a gate. It will prevent you from actually provisioning that non-compliant workflow.
Yeah. Okay, so Yash, I think we've gone through pretty much everything, and I think we're ready for our actual live demo. But before we do that, I think we'll pull for another question here and take some. We'll do a poll and we'll take some questions.
Yeah.
The first thing I'd like to understand from the audience is, how often does security slow down your ISE Terraform deployments? What we just did right now is we implemented a security guardrail, and what that's going to do is it's going to enforce some security principles on our Terraform Cloud provisioning. And if it fails, then it's going to back out of the actual deployment.
So I have to make an admission here. It slows me down very often because I usually try to do something boneheaded, and those gates stop me. So I have to remediate, even though it's part of the workflow and it's doing the right things. I have to remediate because I'm trying to be lazy and just deploy my host with full public internet access to port 22, or S3 buckets that are open to the public internet and not encrypted, and all sorts of boneheaded things like that. But it stops me and it forces me to correct. So thank you for what you've developed.
I hope other people find it as useful as you do as well. And you don't. So yes, you don't write perfect Terraform code right from the beginning.
Oh, it's perfect because I do the Terraform validate before I submit. Perfect doesn't mean that it is compliant and secure. Right? That's
Exactly.
why we have these gates to. I come from I used to be a sysadmin in another life, right? So it was not uncommon to have root to everything. So that really forces you to, have a default posture of laziness. So Terraform and Oak9 together make me do the right things.
You're absolutely right. Okay, all right. So, Yash, I think we're ready to kind of work our way into the next phase of this demo, right? And in this next phase, what we're going to do is exactly what this page says, right? We're going to submit a PR where we'll kick off Terraform Cloud, and we should see that our design gaps are getting returned, where we have a vulnerable API gateway. We'll run a curl command and see that it's vulnerable from the outside world, and then we'll go ahead and patch that up and submit another PR.
Let's do it.
All right. And in the interest of time and being lazy, I'm going to do this edit straight in here, not in VS Code, to save a few clicks and commands on my keyboard. So if we come here and then we go to the code where we actually implement the gateway, there is a section here where we include an authorizer. and we do an API request without an authorizer. So in this very first part, we're going to keep this code as is, where there is no authorizer, and we're going to run it through a pipeline. So we don't really need to make any edits to the code. So in order to just kick off a pipeline, I'm going to do just a dummy edit in one of these files, and to so that we get a check in place, the status check.
So Ramesh, when you say that there isn't an authorizer, that means that that API endpoint is essentially open, that anyone could leverage it without authentication.
Correct.
Right? Okay.
Correct. Yeah. And like you're probably wondering, why would we do that, or why would someone do that? A lot of devs will do local testing, and they'll try to keep things open so that they can test locally, and they might forget to actually enable a custom authorizer after they submitted their code. Or if this is a repository with thousands of lines of code, with tons of developers contributing towards it, someone can also make a mistake of switching off an authorizer or disabling an authorizer. But in terms of API, right, and API attacks, you have a whole wide range of API attacks, right? You have query string manipulation you can do, you have data poisoning that can happen, but the aspect of API security that we're going to cover today is the authentication piece of it. But API general, in terms of security, there's like a book and a half that you probably need to read in order to have a very secure API gateway.
Hey Ramesh, so can you also talk about how Oak9 differs from other open source scanners?
Sure. Yeah. Oak9 is different than other scanners, because what we do is we create a when we scan your Terraform code, we create a meta model on our backend, and this meta model is represented through a graph. And so what happens is, as your reference architecture, or as your architecture changes and evolves, our blueprints dynamically evolve with it. So there is no static checking for a particular file. Everything is dynamically handled. There is no policies that you have to manage. There is no extra tech debt that you encounter in terms of modifying OPA policies. Everything's pretty much handled by our platform.
Excellent. Excellent.
All right, so I'm just gonna come in here and let's do this really quick. Oh, I don't know what I did there. This big font thing and big windows throwing me off. All right.
There you go.
Let's create a branch here.
Ramesh is really good for me. He's creating a separate branch and not just pushing to master like I would do.
All right, there seems to be a little problem here. No worries. I think I've seen this before. I'm just going to add some branch protection really quick, get rid of that warning. So we'll add that so we don't see the warnings in the future. And then if we look at our pull requests, we don't see that our status checks came into play here with Terraform. I think I've seen this as well. And what I've needed to do is manually kick off run yesterday here.
I think if you go into your settings real quick.
Yep.
And scroll down. Let's just double check one thing. Keep going. A little further.
Oh, we do need to update this one to 119. Otherwise, we'll get a warning.
All right. Okay.
All right.
Okay. And then just click on version control on the left.
Let me save this.
Yeah.
Okay.
And it is connected, and it is okay. Always trigger. Oh, you know what? Is it that you have the branch? So
get rid of that.
Yeah. Okay. And automatic speculative plans is checked. Okay, that's good. Yeah. So yes, you can go ahead and trigger under actions on the right side, top right.
Top right. Yep.
Yep.
So we're gonna start our new run here, and we're just gonna
Let's
call
do
it
a speculative plan instead of plan and apply. Plan only.
plan only. Yep. And then we're gonna do. Okay. So what this is actually doing is it's taking what we have in our master branch, and it's going to show us a plan. And then after the plan, it's going to show us our run test that we have configured. And the Terraform Cloud also shows us the cost estimation of these cloud resources. And what we should see is all of our resources that we're going to deploy in AWS to get this API gateway to work. And then we're also going to see the Oak9 run task kick in. And while that's going, it failed. Okay, so yeah, it failed, and it shows one severe design gap. Can you tell me what you think that might be?
I am guessing that Yash got in your repo and left something open. He was lazy. He didn't lock down one of the APIs he added. That's what I got.
And you nailed it. And so if you go into, let me actually zoom in here so the folks on the screen can actually see all this.
Yeah, thank you.
So this shows all the resources that are getting deployed, and it's showing you a nice smiley face, green check mark, or a mean red guy. And so and so if you see this red icon here, you know that this is a bad warning, right, or a bad critical alert. And what we did here is it's saying that our API gateway does not have any authorization set. And what you're essentially saying is, if you allow this, you're leaving your API gateway open to the outside world. So this is a nice little thing to come in here and get a full view of your entire architecture and all your design gaps. So what we're going to do is we're okay right now we're not okay that we're deploying a insecure API gateway, but we are for this demo, so we can actually show you that's insecure. So let's go ahead and kick off another. What I want to do is I want to kick off another. It's going to merge this pull request, and I think that should kick off another Terraform run where the apply actually happens.
Mm-hmm.
All right, so now what we'll see is we're going to apply this. And if you come to runs here, you see that I merged it. And after you merge, a plan and an apply will happen. So here we'll create the infrastructure. While we're waiting for this infrastructure to get created, let's take another poll or our next poll on which of the following slows your deployments down when implementing security guardrails. Kind of similar to the last one, but a bit different. Is it false positives? Is it CI/CD build errors? Is it IAC security review, managing static policies, or it takes too long to find fixes? Managing static policies. Wow. All right, so I'm going to go ahead and confirm this plan. I'm going to get confirm and apply. Okay. It should create my resources. I'm going to open up Postman here. You guys can't see my post. Can you see my Postman?
No, we just see the browser window. maybe
Okay.
that's all that's shared instead of the whole screen.
Yeah, let me go ahead.
You can share the Postman window.
Yeah, let me go ahead and share that really quick. All right, can you see that now?
It is, yes, we see I think we see your whole screen, including Postman in the front.
Okay, perfect. Now let's go ahead and get our API gateway URL and see if everything's good and we deploy this guy. And so there should be an output here where you can cut and paste this base URL. And then what we're going to do is we're just going to post something into our API gateway. We're going to set a record here, and this will kind of show you that it is injecting something without an authorization token. So let's go ahead and just add a record into ID number 7. Okay, and let's go ahead and add another record into ID number 10, just in case, so that when we do a get, all right, those 2 records have been added. Let's go ahead and see if we can fetch those records just to see that our gateway is fully functional. And we'll get number 10, who was John. Okay, so API gateway is working. We have no auth. It's available to the public. Very bad. What we're going to do now is we're going to patch this guy up, and we're going to give it some authorization. And when we do that, we're going to have to pass this authorization header to it. And this is all going to be done via the DevSecOps pipeline, giving us our design gaps back and what we need to do in order to fix this. Okay, so let's go back to our GitHub repo. And we have a time check here, Yash. I think we got 5 minutes. Let's see if we can get this.
Yeah, it's 47 after.
Yeah, in and going. So. Okay, what I'm doing here is I'm taking out the insecure API gateway and adding an authorizer to it. And that's done by this authorization attribute. And this authorization attribute is set to a custom authorizer. So we'll go ahead and submit this code, and we should get no design gaps back. All right, now you see that our health check is actually showing up here, and this is a good thing, right? Because we now have a pipeline where we are doing health checks along with modifying our code. So we can go ahead and open this guy up and look at what we get back for our design gaps and our Terraform Cloud plan output. Plan output is just showing 3 things that's changing. And then, Yash, what do you think the post plan will show for our Oak 9.1 task?
I think you fixed the boneheaded thing I did, so I think it's going to pass. I spoke too slowly, but yes.
and that's exactly it, right? And we got a green. Green is good. And if you go to details here, you will see that you should have no design gaps.
So this acts as essentially a check, and you're prevented from merging that PR, that pull request, if we do have design gaps, right? If we have violations that we encounter.
Absolutely. And that goes back to what you were saying about the advisory versus mandatory. We set it to advisory. So we're just for the sake of the demo, we want to go through and let it pass. All right, so we're going to go ahead and merge this pull request. Everything looks good to us. We're design gaps, no design gaps, and this should add an authorization in play now. And while this is going, I guess we can go ahead and take a quick poll on our last question. How are you identifying security issues early in your pipeline? Are you using open source scanning tools, CSPM enterprise tools, security as code? We don't have that capability today. We're not entirely sure. All right, so let's go ahead and go back to our run. And that's going to be this one right here, right? And we're going to go confirm and apply, and we're going to hit confirm and confirm apply and confirm plan. Apply running. I don't know what that was, but
You can,
okay.
I'm not sure why you encountered that. You can hit the little X. It is running.
Okay, perfect. So let's see if our URL changed. It did not change. So we're going to now try to do the same thing we did earlier and try to inject a new user, and we should get an authorization failed if I implemented this correctly. Unauthorized.
Nice.
Perfect. And so if we add an authorization header, we should be allowed to add this user. So let's go ahead and add 12 John again. And record 12 added. So we have fully implemented an API gateway with an authorization header, and we've implemented an entire DevSecOps pipeline using both Terraform Cloud and Oak9 run tasks. I think we can, if we have time, Yash, we can take some questions. We have a few minutes.
Yeah, let's do it.
Any questions from the audience?
Yeah, so I see one here. Can we keep our Terraform script separate, not in source code, specific branch? So you are, whether you use a VCS connected workflow, as Ramesh demonstrated here, where the repo is connected, or perhaps you have a CI pipeline that calls the Terraform API in order to run that Terraform code. You want to manage your source code, your infrastructure as code in some kind of version control, right? So VCS connected, use GitHub, GitHub Enterprise, Bitbucket, Azure DevOps Services, one of those. If you have some other VCS system, right, that's where you may have it behind a CI system. A lot of times people use a CI system to call the Terraform API because they have some other tasks that runs post apply, right? So you do your Terraform provisioning, and then maybe you call something like Ansible to do some post provisioning configuration, right? So those are all valid patterns, but yes, manage your Terraform code in some kind of a version control system.
Yeah, absolutely. Let's see if there's another question out here.
There's a question on cost estimation. That's just coming back from the public cloud provider cost estimation APIs.
Yeah, that's a little cool little feature, because it kind of gives you a high level overview of what this is going to cost, right? And how much it's going to cost to deploy this particular infrastructure in your. Yep. And it gives you a nice little breakdown here, if you can see my screen, on the IOPS and things like that, and monthly costs and hourly costs.
Yeah, you can then leverage that cost estimation data in a Sentinel policy. We have I'll share in chat one of the policies we have where you can enforce limits based on whether it's dev or stage or prod, if you want to do that.
Yeah. There is a question, where can I find the Git repo to fork? Everything that we did today is on learn.oak9.io. All the instruction sets on where to find the forks, what accounts you need to create, what you need to do. So if you just go to learn.oak9.io, probably just shoot that out there on the chat too as well. All right, Yesh, I think we can wrap it up. I don't think we have anything else that we need to go into detail. Thank you, everyone, for participating in today's webinar. Yash, and thank you for co-hosting with me. It was
Thank you.
great experience. Cody, I'll hand it off to you.
Awesome. Thank you, Ramesh and Yash, both of you, for joining me today. We had a really big turnout, lots of engagement here, so I really appreciate the diligence you took looking at our questions, our chat, and really making sure everybody's concerns were addressed. So thank you both for all of your hard work today.
Thank you for hosting, Cody.
Of course.
Thank you.
So I'd like to remind our audience today that our session was recorded. So if you'd like to rewatch, refollow along, or maybe follow along for the first time at a later point in time, you will be receiving a recording of this session via email, or of course it will be living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. We do have 4 $25 Amazon gift cards to give out. So our winners are Christine J, Puneet T, Branson D, and Mina B. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should arrive in about the next 48 hours. If you don't happen to see that email, please do check your spam folder just in case it gets filtered out. I'd like to thank Oak9 for sponsoring our program today. And to everyone who has joined us for the last hour, thank you for being here. We really appreciate your time, and we'd like to hear your feedback. As soon as we close out, there will be a survey that pops up, so let us know what your thoughts were on our program, or perhaps what you'd like to see on an upcoming program. Either way, we hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and Yash, Ramesh, thank you both so much once more.
Thank you.
Take care.